Find the Laplace transform of the given function. In part A, we got a function, a piecewise defined function. So this function can be written as, this is same as using unit step function, the first piece, which is t squared, plus second minus first, okay, that is 1 minus t squared times the unit step function at 3, because these two pieces differ at 3, so u3t. Okay, so this function is same as this. Now let's take the Laplace transform. Then Laplace transform of this lowercase f is uppercase f equals, we got two terms here. So Laplace of t squared, look at the table, that is just 2 factorial over s cube, and 2 factorial is 2, plus, now we need to work a little bit for this. Look at the table and you have the following formula. When you have some function, let's say gt, and unit step function uct, and when you find Laplace, this uct is negative e raised to negative cs, but this gt is Laplace of gt plus c. Okay, we need to shift this plus c. Okay, so let's apply this to our problem here. Then we get u3t, so e to the negative 3s, and Laplace of, we need to shift this 3 units, so 1, no shift, minus t squared is in fact t plus 3 squared. Now we need to take the Laplace of this. Okay, and this is because of this rule. Now let's work on this, and this is, first part is easy, this is done, this is also done. Okay, this is Laplace of, we need to simplify inside, this is t plus 3 squared. T plus 3 squared is in fact t squared plus 6t plus 9, basically FOIL, and we have negative in the front means negative, 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 and there is 1, so plus 1 means this is in fact negative t squared, negative 6t minus 8, okay, negative 9, and we have 1. So we need to work on this Laplace transform. Look at the table, and we have, this is 2 over s cube plus e to the negative 3s, negative t squared. Okay, the first one is t squared, that's 2 factorial over s cube, minus 6 times t, 1 over s is squared, minus 8 times 1 over s, or 8 over s, final. Okay, in part B we have a piecewise function. We got 3 pieces, so this is same as first piece plus second minus first, t minus 1, and these two functions differ at 2, so u2t, plus third minus second, and second and third differ at 5, so u5t. So this is how we write a piecewise defined function with the help of Heaviside function. Then let's take Laplace of this little f, which is uppercase f equals, so here we got 1, 2, 3 terms. This is pretty much negative t. Okay, now Laplace of 1 is 1 over s, plus, for this now we have to apply the same rule like above. When we have function, let's say g and uct, Laplace will be, because of this uct, e to the negative cs, and Laplace of not only g, it will be gt plus c. So in this case, e to the negative 2s, Laplace of this t is now plus 2, so t plus 2 minus 1. Okay, this is negative t, by the way, negative t u5t, and the Laplace is e to the negative 5s, and Laplace of, we have t, but there's a 5t plus 5. Okay, just using this. Now we can finish the problem in next line. Okay, which is 1 over s plus e to the negative 2s. Let's find the Laplace of this. Here, this is t plus 2 minus 1 is t plus 1, and Laplace of t is 1 over s squared, and 1 is 1 over s, minus e to the negative 5s, and inside t plus 5, Laplace of t is 1 over s squared plus Laplace of 5 is 5 over s. Final.